Welcome back, students, to geology. Now that we know something about continental drift, the rise of plate tectonics, and what is just driving all of this, we are going to focus specifically on each plate boundary. This first one we'll focus on in this video is divergent plate boundaries. Where is Earth created? So your pondering question for these slides are, what clues suggest this rift valley that you see in this photograph could create or become a new ocean? So this rift valley is just that. It's a valley that is rifting apart. And how could it create a new ocean? So let's back up really quick and remember what plate tectonics was. Remember, this is the scientific theory that Earth's lithosphere is broken up into these tectonic plates that are moving slowly in different directions for about 3/4 of Earth's history. And in this one, we're going to talk about the tectonic plates one more time really quick, and then we're going to look at divergent plate boundaries and some examples. So again, here are 7 major plates: North America, South America, Eurasia, Africa, India, Pacific, which is our largest, and Antarctica. Again, the map also shows you some of the smaller plates that are present on Earth as well. Okay, so before I talk about the boundaries, let's revisit the layers here. Remember, we have an inner core that is solid, an outer core that is liquid, a mantle that's broken up into an upper and lower, and then we have the crust. But we also need to talk about the lithosphere and the asthenosphere. So the lithosphere is the crust and uppermost solid part of the mantle, and this is what makes up tectonic plates. Okay, and then the asthenosphere is the upper mantle that is mechanically weak or ductile, or maybe you might want to refer to it as molten, that plates can slide on. So I like to use the Oreo cookie example. So if you have an Oreo cookie and you take the top part of the cookie part, the crunchy part off, and you break it up into 2 pieces, and you try to move it around on the crane. Okay, so the cookie part that you just broke apart is the lithosphere, and the asthenosphere is that cream filling that allows for movement to happen. It's mechanically weak, it might be molten, but it's not liquid, right? And so that's how the lithosphere, or the cookie, would move along the asthenosphere, which would be the cream. Okay, so kind of think of that as we go through this. So we have 3 types of plate boundaries. We're going to first talk about divergent, then we'll probably jump into transform, and then we'll do convergent last because it's a little bit bigger of a beast, because there are 3 different types of convergent depending on plate-to-plate interaction. Okay, so we're going to first look at divergent plate boundaries. These are our constructive margins. They're formed from tensional stress, so full pulling apart. We call them constructive margins because they are constructing new crust. Our convergent plate boundaries are destructive margins. They are formed from compressional stress, so pushing together, and we call them destructive margins because they destroy rocks, and we'll get into that when we get to that lecture. And then transform plate boundaries we call conservative margins. They are formed from shear stress, so sliding past each other, and they're conservative margins because they don't create or destroy anything. They just bump into each other, and sometimes there's a little bit of crumbling that occurs. Earthquakes happen, of course, but we don't have any new rocks being formed, and we aren't destroying old rocks either. All right, so divergent plate boundaries. This is where 2 plates are pulling apart from each other. Plates move away. This movement results in the creation of new crust. So magma rises and fills in that void space. Okay, the mantle is what is providing that magma, and the crust is what's providing the void space. They're responsible for continuous reshaping and formation and the creation of that seafloor spreading ridge. All right, so looking at the development, if it's not already occurring in the middle of an ocean, it might start by a specific continental plate pulling apart. So things start to pull in either direction. So you have like a convective cell that's coming up and it's pulling the crust apart. When that happens, the crust starts to thin, and when it thins, it cracks and it creates what we call a rift valley. So think about the pondering question I gave you at the beginning. Creates a rift valley, and then eventually that part of the crust gets so thin, water starts to fill in. And when water accumulates, we might see an inland sea develop, and then over time, it's going to create an entire ocean. Okay, so this is actually happening right now on Earth, this exact process in East Africa. We call it the East African Rift. Maybe you've heard of it, maybe you haven't. But the Arabian Peninsula here at the top right of this map is pulling away from the main African plate. And in doing so, it's opening up the Red Sea, it's creating these rift valleys, and you can see that most of East Africa here eventually will be a completely separate continent from the main continent of Africa. And so the East African Rift is a perfect example of watching a continental plate rip itself apart, which is kind of cool. And then this is also happening on land at the mid-Atlantic Ridge, which is the divergent plate boundary that runs up and down, or north and south, through the Atlantic, and it happens to propagate through Iceland. And so it's pulling Iceland apart. Iceland is an island that sits on both the Eurasian and the North American plate. And the middle of it has these huge cavities, and there's lots of volcanic activity. There's a really cool influencer on, I think he's on Instagram, he's probably on TikTok too, but he takes a drone and he takes his drone through these volcanic eruptions on Iceland, and it's really cool. I don't know how he doesn't melt them. He probably has, but there's some really cool videos out there of Iceland erupting because it happens nearly every day, kind of like Hawaii. Hawaii is a different story, though. We'll talk about it in a little bit. But Iceland happens to sit right on this mid-ocean ridge or mid-Atlantic ridge that's being ripped apart. All right, so those are divergent plate boundaries. In your notes for final thoughts, I want you to explain what happens at a divergent plate boundary in one sentence, and that will help you conceptually understand what's going on. I will see you guys in the next plate boundary. Bye.